I want to go through some more examples of solving systems of equations by substitution. So let's say that we had 2m minus 4n is equal to 4 and 3m minus 2n is equal to negative 6. The first thing you'll notice there probably is that we don't have x and y, we have other letters, m and n. And you need to get used to being able to do algebra with things besides just x and y. As you move further towards pre-calculus and calculus, you're going to need to work with other things. So don't just replace the m and the n with an x and a y to work this. Keep the letters that are there and get used to it. So with substitution, we want to look for one equation and see what variable is easiest to solve for. If I were to add 2n to both sides of this equation, the second one here, that gives me 3m, isolated pretty easily, and then I have to divide by 3. But 2 divided by 3 gives me a fraction, so I don't know about that. If I look at the first equation and I move the 4n over by adding 4n to both sides, now I have a 2m, so I'm going to divide by 2. Well, 4 and 4 both divide by 2, so that's going to work a lot better for me. So even though I don't have any equation where a variable has a coefficient of 1, that first equation is definitely my best bet, and I want to solve it for the m. So if I'm adding the 4n to both sides, 4n to both sides, that gives me that 2m is equal to 4n plus 4. Again, the 4 and the 4n, when I'm adding, are not like terms, so they do not combine. You just have to put a plus sign between them. My next step is to divide both sides by 2. You will remember, however, that when we divide, we have to divide both of the terms over here. We have to divide the entire side by 2, which means we're actually going to end up distributing that division there. On this side I get m by itself, which was the whole point. Then 4n divided by 2 is 2n, and 4 divided by 2 is 2. So now I have this expression, and I'm ready then to take this and plug it into the other equation in place of the m. So I get 3 times the expression 2n plus 2 using parentheses minus 2n is equal to negative 6. I now have an equation all with just one variable in it. So like we said before, you're going to first do the distributing here. So that gives me 6n plus 6 minus 2n is equal to negative 6. I'm going to combine those like terms. The 6n and the minus 2n is a 4n plus 6 is equal to negative 6. I will then subtract 6 from both sides to get rid of that constant there. And that gives me 4n is equal to negative 12. I then divide both sides by 4. By the way, the reason I'm showing these steps in green highlighter is because those are steps that you actually don't have to show if you can do them in your head. You should be able to just know I'm going to divide this side and this side by 4, and that this side will give me n, and this side will give me negative 3. So now I've solved for one of my variables, n. I take that and plug that back into my substitution equation to get my other variable. So m equals 2 times negative 3 plus 2. That is equal to negative 6 plus 2, which is negative 4. Therefore, my solution, I really shouldn't write this one as an ordered pair, because when we see an ordered pair, we're thinking about graphs where we have graphed x and y. You could argue that we go in alphabetical order, just like we always do, but I think it's much clearer to just spell it out there. M equals -4 and N equals -3. So be wise when you're choosing which variable to solve for. Even if there's coefficients besides 1 on all of the variables, there are some better ways to approach this. And that's just going to take a lot of experience and practice and just a keen eye. Here's my next one. 2x minus 4y is equal to 8. 3x minus 6y is equal to 12. Both of these are going to be pretty easy to solve for x because 4 and 8 both divide by 2 and 6 and 12 both divide by 3. So really doesn't matter. I'm going to go ahead and go with the first one. So 2x minus 4y is equal to 8. I am going to add 4y to both sides, which you could either just do and know what you're doing and get to the next step by just sort of skipping, or you can show yourself like I'm doing here in the green. This side gives me 2x, and over here I get 4y plus 8. Then I need to divide both sides by 2, and I mean divide the entire expression by 2, which then is going to mean distributing that division over here across the addition. What that will give me here is x, and over here 4y divided by 2 is 2y, 8 divided by 2 is 4. And now take that, plug it into the other equation in place of, wait, I solved for x, so I need to plug it in place of x into the other equation. So we get 3 times the quantity, 2y plus 4, minus 6y is equal to 12. Distributing here, as we know we need to do, is going to give me 6y plus 12 minus 6y is equal to 12. And then if I combine my like terms, the 6y and the minus 6y are like terms, so that's 6y minus 6y is 0, 0y, and 0 and 12 is 12, and I get 12 is equal to 12? Well, yeah, everybody knows that, but what happened to my variables? What is going on here? Well, let's come over and let's use GeoGebra to look at this and kind of try to see what's happening here. What is going on with this? So I'm going to come in here and I'm going to graph both of those equations. 2x minus 4y is equal to 8. And then I'm going to graph 3x minus 6y is equal to 12. And when I do that, it's a little bit difficult to see here, but those equations actually lie on top of each other. They're actually the exact same equation. I can see that a little bit better if I sort of change the coloring on the two equations. And this one I will do with a green. I'll do it a lot thicker, and I will dash it. And so now you can see there, the green and the red line, they're really the same line. And in fact, on GeoGebra, it simplified both of those equations, and you can see that they're the same. So how many places, or where do they intersect? They intersect at an infinite number of points. It's a little bit of a strange situation, but it can happen that two lines are actually the same line, just written in a form. So when you get an expression like this where you just get 12 equals 12, or -7 equals -7, or 0 equals 0, what you would say is that there are an infinite number of solutions. There are an infinite number of solutions. Now that doesn't mean that just any point will work. There's only the points on the lines, the two overlapping lines, only those points work, but there are an infinite number of points in there, so an infinite number of solutions. Sorry about the writing there. And that's certainly a possibility of what could happen. Let's go look at another example here. 2x minus 3y is equal to 5, and negative 6x plus 9y is equal to 11. Now when I look at this situation, if I try to solve for x by just adding the 3y over, I'm going to be taking 3 and dividing by 2 and 5 dividing by 2. That's not going to work out so well. But if I look at this one, maybe I'll keep the 9y since it's already positive and I move over. Well, 6 divided by 9 is a fraction, and 11 divided by 9 is a fraction. So I'm not going to be able to avoid any fractions here. I'm going to have to work with some fractions. I think dividing by 2 gives me the easiest fractions to work with. So I'm going to take 2x minus 3y is equal to 5. I'm going to solve by adding over 3y. I'm going to go ahead and kind of skip some steps here. And then I'm going to divide by 2. Got to divide both of these terms by 2. That's going to give me a 3 halves y plus 5 halves. I then take that, substitute it into the other equation, so I get negative 6 times 3 halves y plus 5 halves plus 9y is equal to 11. Now I need to remember a little bit about how to work with fractions. If I take negative 6 times 3 halves, just looking at that fraction part, that's really negative 6 over 1 times 3 halves. You could go ahead and just multiply across there and do that multiplication, but you also could remember that you can do cross-canceling first, where you divide numerators and denominators by the same number. Here, if I divide this by 2, I get a 1. Here I get a 3. So what I end up with, if I really understand fractions, is negative 9 divided by 1, or in other words, negative 9. So that worked out really nicely. Then the negative 6 times the 5 halves. Again, if I do the cross-canceling, which I really shouldn't even need to write this as an over 1. I should know that that's in the numerator. That now gives me negative 15. So distributing here, this negative 6 is going to actually end up giving me a negative 9y minus 15 plus 9y is equal to 11. Negative 9y plus 9y is 0, so I get negative 15 on that side is equal to 11. Well, now we have another very strange situation. If I come over here pretty quickly and graph those two lines on GeoGebra, I get 2x minus 3y equals 5. And then graphing the other one, I get negative 6x plus 9y equals 11. What I see now is that I have two parallel lines. These lines actually have the same slope. They are parallel. They are never going to intersect. What I'm noticing here is that I got the variable to cancel out, and now I get a number equals a number, but this time it's not a true statement. Negative 15 does not equal 11. There's no way for that ever to happen. No choice of x and y will ever make negative 15 equal to 11. These two graphs do not intersect. Therefore, this system has no solution. So that shows you a couple of possibilities that could happen. You get that a number equals itself, which is always true. There's a lot of choices for x and y that will make that happen, so you get an infinite number of solutions. Or you get a nonsense statement like negative 15 equals 11, and that is your hint that there is no solution. But I very strongly recommend that you're using some sort of graphing software, Desmos or GeoGebra, to graph your equations and check your points of intersection and to check your solutions on your systems of equations.